Hi, 7th graders. Today we're going to be talking about triangles and how we can classify triangles by their sides and by their angles, as well as discussing quickly about the triangle sum theorem. So, a triangle is a three-sided polygon. It's made up of sides, angles, and vertices, which is the plural form of vertex. So a triangle can be classified by its sides and the angles. So over here it says name the triangle to the right, triangle LOG. Notice that there's that little triangle symbol in front of the letters LOG. So that means that LOG are going to be our vertices, and then that little triangle is how we would name it. Just like when we name an angle, we use that little angle symbol. So we are going to go ahead, and it says to, we're going to label it L, O, and G. All right. And it says label the sides in blue. So I'm going to go ahead and just highlight the sides in blue. Here is one side, another side, and another side. Shade the angles in green. So I'm going to use my highlighter tool to shade in our three angles, which is why it's called a triangle. And then point out the vertices in orange. So we have a vertex there, there, and there. So a couple of ways that we can classify our triangles. We can classify it by the sides. So here it says no sides, and then you see this funky little symbol. It's the equal sign with like a little wave on it. This symbol is the congruent symbol. So what this is saying is we have no sides congruent, which again, we should know means equal. All right. So if we have a triangle that has no sides that are equal to each other, what we call that is we call that a scalene triangle. So that's scalene triangle. If we have at least two sides that are congruent, so again, you see that congruent symbol there, the equal sign with the little wave on it. Congruent means equal. So if we have at least two sides that are equal, we call that an isosceles triangle. And you'll notice that they usually tell you sides are congruent by putting these little dashes through them. Not always, but typically if they want you to for sure know that sides are congruent, you're going to see those little dashes through the sides. So then over here on this third triangle, it says all sides are congruent. And again, notice that here we actually have double dashes. That's to tell us that this side's not necessarily congruent to these sides on the isosceles triangle, but that these three sides are all congruent to each other. So when we have a triangle that has three congruent sides, we call that an equilateral triangle. So equilateral literally means equal sides. Lateral is sides. So you'll use one of those three words to describe and classify a triangle based just off of its sides. We also have a set of words that we can use to classify triangles by their angles. So I'm actually going to start over here on the far right on this one. So if we have all angles congruent, we call this an equiangular triangle. So again, equal angles. And then one thing to know is that every equiangular triangle is automatically going to be equilateral triangle. So for every set of equal sides, there are equal angles. So like an equilateral triangle has three equal angles as well. An isosceles triangle will have two equal angles. When we have all of our sides having angles that are when we have a triangle with three angles that are all less than 90 degrees, we call this an acute triangle. Okay, because acute angles are less than 90 degrees. So when all three of those angles are less than 90 degrees, we call it an acute triangle. And then when we have one angle that's greater than 90 degrees, so an angle greater than 90 degrees, we would call that an obtuse angle. So we're going to call this an obtuse triangle. And really quick, just so that we're all on the same page here, notice that it only says it just needs that one angle greater than 90 degrees. So if you were to try to draw a triangle, so here's an obtuse angle. If I tried to draw a triangle with a second obtuse angle, notice that it's not possible. All right, I'm not going to be able to make a triangle anymore. Okay, it's automatically going to become a quadrilateral at least. So that's why we only need that one angle greater than 90 degrees. Same thing over here. When we have one 90-degree angle, we call this a right triangle. And again, we just need the one 90-degree angle, because if I try to draw a triangle with a second 90-degree angle, I don't have a triangle anymore. So what that means is that all triangles are actually going to have two acute angles always. Okay, so every single triangle has at least two acute angles. You want to make sure you always look at that third angle to determine if it's an acute angle, a right angle, or an obtuse angle. We're going to skip that. And so we have right triangles, are triangles that have two legs, and they can be congruent, but they don't have to be. And so we actually call the legs of the triangle are the sides that make up the right angle. So this would be a leg, and this would be a leg. A right triangle also has something called a hypotenuse, which is the side across from the right angle. And the two angles on the other than the right angle are always acute and complementary. So here it says the acute angles of the right triangle shown measure x plus 4 degrees and 3x plus 2 degrees. And it's saying to find x and the measure of both angles. So one thing that is going to be true about triangles, and this goes into the triangle sum theorem, is that all angles in a triangle will always add up to 180 degrees. So the sum is always going to equal 180 degrees of the three angles. So for example, if I was given this information, I know I have that right angle, which we know is 90 degrees. And what we can do then is we can set up an equation. So I know that 90 plus the x plus 4 degree angle plus the 3x plus 2 degree angle all is going to need to equal 180. So I have an equation now. What I can do here is I can then combine like terms. So when I look at this, I see some constants. 90 is a constant, 4, and 2. And so if I go ahead and add those up, I'm going to get 96. And I also have some like terms with my x's. So I have a positive x there and positive 3x. So I have 4x plus 96 equals 180. And then we just go about solving our equation. So I can subtract 96 from both sides. And then I'm going to end up with 84. So 4x equals 84, divide by 4. And so now I can solve that x is going to equal 21. All right, so that's what I know, but now I can go ahead and plug that back in to solve for these acute angles. So my x plus 4 angle up here, if I plug in 21 for x, 21 plus 4 is going to give me 25 degrees. And then I probably reversed the way that these should be, but and then if I look at my 3x plus 2, so I'm going to do 3 times 21, which is 63 plus 2 would be 65 degrees. And again, these aren't necessarily, I think technically they should be, this one should be our 25-degree angle, and that should be our 65-degree angle. But the point is that we were able to use the information that the angles are going to add up to 180 degrees to help us solve for a variable there. Isosceles triangles have two legs and the sides that are congruent, so we can call this a leg and this a leg here. And then they have two base angles on either side of the base, and the base angles are congruent. So again, because we have two sides that are congruent, two of my angles will be congruent as well. And then there's a vertex angle between the two congruent sides. So it says label the legs, base, vertex angles, and base angles of the isosceles triangle. And then here it says the base angles of the isosceles triangle shown measure 2x plus 40 degrees and 5x plus 16 degrees. Find x and the measure of both angles. So again, we could use an equation to help us solve for that. And then for equilateral and equiangular triangles, since all the sides are congruent, all the angles will be congruent. Equilateral triangles are always equiangular and vice versa. And because all angles are equal, each angle is always going to be 60 degrees. So that's just a little bit about classifying triangles and the triangle sum theorem. Have a great day.